Thank you, everybody. Good night.
Doesn't have any, sorry, goes on.
How many straight edges?
So basically, you guys have all seen this. The standard form of an equation of a circle, but last year you guys saw it like this.
What if you've never seen that? Does that happen?
You took geometry last year?
Yeah.
Yeah, I
You did
never
it.
saw that either.
You did.
Yeah, I don't know. You joking. Wait.
You guys did this. You guys did this.
Squared plus y squared equals r squared.
Yep. This is the equation of a circle centered at the origin. Okay.
If Busy didn't see it, no one saw it.
It doesn't matter. I'm still going to show you how to do it. Okay. So even if you didn't see it, you will see it. It's really easy to do. Okay. So today we're talking about circles that will be centered at the origin. And that means that your h and your k value are both 0. There's no horizontal, there's no vertical shift to it. Everything will be placed at the origin, and then your radius is just going to be some value r. The generic form of every circle is always going to be written in this conic form called x squared plus y squared equals r squared, where r is going to be your radius. So if you had the equation x squared plus y squared equals 9, well, it's centered at the origin. And what's the radius? 3. And there's your circle. That's it.
I remember this one. I think it was a little more complicated.
Well, it was more complicated last year because you did have it centered at different places. You had it written as x minus h quantity squared plus y. You had it there where your h and k was the center of the circle. So it just moved it in space.
I think, yeah.
Okay.
I like
You-
yours better.
What?
The y x squared plus y squared equals.
Oh, we're going to do that other stuff though too.
Wait, it's not the same thing? Is it just?
It is it's basically the exact same thing, because here, if I wanted to say that your center is at the ordered pair of -2 and 3, my equation would just been x plus 2 quantity squared, y minus 3 quantity squared, and say it had a radius of 4 equals 16. That's all it is. That's all that would be. And if I had to plot that, it's the same idea where I would just move it into space. -2 and 3, and then I just go up, down, left, and right, 4.
Because that's the radius.
Yep, that's all I'm doing. So shifted circles are nothing. They're easy. Of all the conics, it's the easiest one to deal with. It really is. Because I know last year you guys did a little bit of that. Yes, sir?
So is the x squared plus y squared equals the radius would say that the x minus h is there?
Yeah. Where h and k, right now our h and k are just at 0 because we place them at the origin. That's all. You will also see that as we go through these, as we build into this h and k, not so much today, but as we build into that, we're going to be doing a lot of completing the square. Because you're going to be able to create a perfect square given specific setups. This is why one of the reasons that we do the complete the square. This is why we do completing the square in chapter 5 stuff, and this is where we use it a lot. Okay, we might not use it a ton today, but I can guarantee you tomorrow we'll probably use it at least once or twice. All right. So working with circles, it's going to be relatively simple. If I want to graph the equation of the circle that's given to us by this, y squared equals 25 minus x squared. Well, today, like I said, everything's going to be centered at the origin, so it should be pretty happy time. We just need to get it in that standard form. Well, if it's y squared equals 25 minus x squared, how do you get it in the standard form?
X squared.
Just add the x squared over. So you get this. What's your radius? 5. That's it. Graph it. Are you okay with me marking those tick marks like that? Ready? Squint looks better. is to it, guys. A lot of you will be happy with, and I said this before, with conic stuff, as we get going, it's a lot more procedural. There's really only one way to do a lot of things. There's not a lot of interpretation of the data or anything like that. What is this X actually representing? How do you utilize that and solve another problem? This is just kind of, let's make a comic and be happy. Oh, I know. Oh no, I am so afraid. 32 isn't a perfect square. What do I do for my radius? You do.
Just find the square. Just find what it is.
Now, here's what we do. When we go to graph something like this, when we go put it in space, we obviously, everybody agrees that the radius is going to equal the square root of 32. Square root of 32 is simplifies to be what? You're getting there, but can we do 16 and 2? So it would be 4 root 2. What you were doing is going to be fine. You would eventually get, you would have just taken, you would have simplified it twice. So this is the same thing as saying 4 root 2. So that's my radius. In what I'm going to do is have everything simplified in simplified radical form for my radius. But when I go to plot that, I got to take a guess as far as where does it go when I graph it. Well, we know where we're at the origin. 32. 32 is in between what two perfect squares?
16 and...
Hold on. 25 and 36. So the square root of 32 is smaller than the square root of 36, but yet it's bigger than the square root of 25. Which one is it closer to? 36. So it's more. Is it more than halfway to 36?
Yeah.
Yes.
Yeah.
Maybe like
5
and 7.
Sure. So if we do 1, 2, 3, 4, 5, 6, and just put it in between 5 and 6, we can call it a day. Is that okay? We're guesstimating. We do a lot of that. Okay. There's when we get into ellipses and we get into hyperbolas, we're going to be walking radical distances pretty regularly to plot things. And we're going to guesstimate distances kind of using this method a lot. Have you guys ever done that before, estimation like that? Does it make sense though? We do it a lot because when we start talking about ellipses and we start talking about hyperbolas, what's going to happen is that you'll have a center, a focus, and a vertex. And these values, and we'll have covertices out this way, these values all have specific distances and how they interrelate to the center, to these parts. A lot of them are going to have radical distances to them. And it's very, once we get the idea of how they plot themselves through, it's very, very easy to work with. Okay? But we use that a lot, just kind of guesstimate. Okay? And then obviously last but not least, I was pretty close on mine. I set that up, I'm probably. That's not bad for just kind of winging it.
It's not bad.
I'm impressed with myself. More so than normal. Are you trying to be impressed with yourself too?
Yeah, check it.
Wow, that looks like a rugby football. What is a rugby football called? Rugby football? Or
We still call it football.
Where's Glenn?
A football in
Go ahead. No, I think it's called the rugby ball.
sure. The point 1,4 is on a circle whose center is at the origin. Write the standard form of the equation of the circle. The point 1,4 is on the circle whose center is at the origin. Write the standard form. So,
Was it into your X and Y?
no, not necessarily. Your center is at the origin. Your H and K are both 0 in this case. Okay? Now, this, excuse me, the point 1,4 is over 1 up 4. How do I figure out that radius?
Yes, about 5.
What's created here? A right triangle. Isn't the radius the hypotenuse? Yes, ma'am. If you want, but isn't it easier just to do, isn't the distance formula Pythagorean theorem? Horizontal change in x, vertical change in y. You didn't notice that? Yeah, that's all it is. And that's a good question. Whenever we do, what do you call it? Pythagorean theorem?
So 1 plus 4, 1 squared plus 3
Yeah.
plus 6.
The horizontal distance and change there, well, it's the distance between 0 and 1. 1. So you would have done 0 minus 1 quantity squared, which is still 1. Vertical change, 0 to 4. That's still 4. So all it is 1 squared plus 4 squared equals what? 17. But 17 is that our r squared or our r?
That's r squared.
That's r squared. Do I need to worry about writing down the square root of that? No,
Yes.
because the standard form of the equation is x squared plus y squared equals r squared. Oh. And you're done. Your answer is x squared plus y squared equals 17. That's it. Well, your radius will be the square root of 17, but do I need to worry about writing down that? Because the formula said it's just x squared plus y squared equals r squared. Right. Oh, let me tell you a little trick here, guys. This whole circle with the right triangle in it, the unit circle is built off of circles with right triangles. Everything we do basically when we get back to second semester, I think we start with logs, but then we go right to right triangle trig, and we spend our lives in a circle, running around and around and around in the abyss of nothingness. It traps you, it makes you stay there. It's so much fun. I love trig. Trig is great. Let's try this one. Take a second and do these two. Write the equation of the circle in standard form that have the centers at the origin today. Don't have to worry about any h and k. And then we're just going to go for those points are on the circle. Now later on when we do shift it, yes, that distance formula might come into play, but you'd be surprised, I have a shortcut for it. It's a lot less work. We all can count, right? Well, I can do that. Yes, ma'am. You don't have to. Yeah, that's a shortcut. The shortcut. For today, yeah. But later on when I have the center placed someplace else, if it's at like 1, 5, then you have to figure out the distance between the point to that, and you could use this as formula. Triples.
Oh, I don't remember those.
Parentheses around -8. Parentheses around -8. You'd be surprised how many people screw that up. Don't kill puppies. Squared is what, 169? I believe. Is that right? That's it. That's really all there is to it. So the last bit of this then. Finding tangent lines. Finding the equation of the line that is tangent to something is one of the more upper level math things that you will start to see I'm going to try and do this a little bit more this year, as opposed to what I've done in the past about writing equations, lines that are tangent. What happens is that this is kind of like the precursor to calculus. What we're going to try and do a lot of times when we get to calculus is find the slope of the tangent line. What that means is that you're going to find the slope of the line that touches the curve at a specific point. And what that allows you to do later on is there's other ways of doing max mins, things like that. It's, what is it called?
Stupid.
No, it's not stupid. It's average rate of change. That's one of the things that we look at sometimes as well. There are some average rate of change problems that are in the new book. I think it's with polynomials though, so we'll look at that when we get there. It's a fairly simple process to do it. And again, it's not like you have to interpret data like you were doing a lot of times. It's a process you follow to do the problem. And it's kind of the same thing over and over with numbers changing. These are the things that I know that you guys like. There's not much thought involved. When you have to think, become independent on these things, that's when you kind of go, did I have to think? It's okay, we need to learn how to do that too. So anyway, what we're going to do here is we're going to use a lot of times point slope form. Do you ever heard of point slope form? We use point slope form, and we also talk about what it means to be tangent. When you're tangent to something, what's created? What is it? A right angle. So we know that when things are tangent to one another, it's perpendicular at a specific point. If something's perpendicular in terms of slopes, what are perpendicular slopes? Remember that? Opposite reciprocals, very good. So perpendicular slopes are going to be opposite reciprocal slopes. For example, if I have an original slope, let's say it is 3/4, what would the perpendicular slope to that be? Good. So the perpendicular slope would be -4/3. Are you guys okay with me just using perpendicular symbol? I don't like to write. Spelling is hard. Okay. Now the other thing is that what happens if your original slope is 0? What's your perpendicular slope to a slope of 0?
0.
No.
-0.
There's no such thing.
Undefined.
Undefined. Undefined. What kind of lines have a slope of 0? Don't say straight.
Horizontal.
Horizontal, very good, because what's the second letter of the word horizontal?
Zero.
See? That's how it matches. What kind of lines are perpendicular to horizontal lines?
Vertical.
Vertical lines. Vertical lines always have a slope that is undefined. That's how that works. Okay, that's how that works. And yes, it's the dumbest way that I always remember that horizontal was always 0 because the second letter is O. O is at 0. I got dropped in my head twice. Find the equation of the line that is tangent to the circle, y squared, or x squared plus y squared equals 13 at the point 2, 3. Excuse me. Square root of 13 is more than the square root of 9, but it's less than the square root of 16. So there's 3, 2, 1. Everybody okay with that? Just to try to get an idea. And I want to be at 2 and 3. Now, if it is tangent, it means it's going to be tangent to the radius. And then it comes across that, and we get a right angle. That's what it's going to look like. Now, remember in circles last year in geometry, we talked about point of tangency, where it touches the circle at one spot, and it is perpendicular to the radius. That's where this comes back into play. Now, excuse me. What we know is that we know the center of the circle is at the origin, at 0, 0. And I know that this point here is at 2, 3. And what I want to do is find out the equation of the line here. Well, in order to do that, the first thing I'm going to do is figure out the slope of that line. Well, the slope of that line has to be the perpendicular slope to the slope that's created by the radius. How do you find slope? Slope is changing what or changing what?
Change Y over change in X.
Slope is the change in y over the change in x. In this case, we write it out long form, and I'll show you the shortcut here in a second. y2 minus y1. Isn't this, if this is my first set of y values, x and y values, these are my second set, isn't it just going to be 3 over 2?
Yeah, and then the opposite reciprocal of that is -2/3.
What's nice about this first unit, saying that we're going to be centered at the origin, you have a lot less work involved as far as finding slopes. Because you can just go right off the fact that in this example here, it's going to be 3 over 2. My slope is going to be y over x because I'm at the origin. No matter where it's placed, whatever quadrant it winds up being, the slope of the radius is always going to be y over x today. Okay, it's always going to be just y over x. So if my original slope is 3/2, what's my perpendicular slope?
-2/3.
Now I have a slope and a point. Do you remember what point slope form looks like?
Y minus Y1 equals M times X minus X1.
Perfect. Point slope form, y minus y sub 1 is slope x minus x sub 1. Hey, did you guys know that that's just an h and a k hiding as y sub 1, x sub 1? It is. It's just an h and k shift from the origin. So here's what happens. Fill in the blanks. Y minus 3 is -2/3 x minus 2. Distribute and solve for x. I'm sorry, solve for x. Solve for y. So used to solving for x. When I add 4/3 to 3, 3 can be rewritten with the denominator of 3 by turning it into
Wait, what's the denominator?
9/3. Yeah, because I have to have common denominator. Your answer would be y equals -2/3 x plus, this is the same as 9/3. Do you guys know how to do that in your calculator? I will show you. On your calculator, if we do bless you, we do an alpha y equals, and we create a fraction, 4/3, and then just, I don't know, add 3. Hallelujah. Hallelujah. Not magical. Not magical. La, 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 la. You guys don't like my singing? Try. That's really all there is. Should we do another one? You'll see that there's some shortcuts. Wait, what's your answer? Yep, write the equation of the line that is tangent to the circle at a specific point. That's it.
Wait, can you repeat that?
That.
Break the equation that's
You should just give us the one.
Yeah, it's going to be written just like this, where it says, write an equation of the line that's tangent to the circle, blah, 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 at a specific point. That's what it's going to look like. All right? Yeah, no one here. Let's do one more. Doesn't hurt.
And we're writing it in y equals mx plus b.
Yep. And we always want to go to y equals mx plus b because we can put it in our calculator. I'll show you guys how to graph a circle with the tangent line here in a second. We'll graph this one on our calculator too. It's kind of cool. So we have x squared plus y squared equals 5, which means my radius is going to be the square root of 5. And then it also wants you to be tangent at the point 2, 1. So yeah, whenever your answer is always going to go to slope intercept form when you're done, we use point slope form to get there. Okay. I know some people use points, don't use point slope form. Some people just substitute in your x and y value and solve for b. If that's the way that you do it, that's fine. But your final answer should be in slope intercept form. I always thought that using slope intercept form was easier because you just have to move one value. That's all. So visually, my radius is the square root of 5, which means it's just a little bit more than the square root of 4. Points right here. I'll be tangent to it. There's my radius, perpendicular. So the radius has a slope of what? Well, the radius, the slope of the radius.
1/2.
1/2, very good. So the slope here is going to be the change in y, so it's 1 over change in x, 2. Which means my perpendicular slope was -2, very good. And I have a point, 2, 1. Y minus 1, -2, x minus 2. And I get that. And there's my equation of the line. Really, really fast when we're at the origin. Okay. Now, let me show you something that's kind of cool about how you can graph all these things on a calculator, just because it's fun. Your calculator has a button at the top left corner that says what? Y equals. Which means if I solve this equation to get y by itself, what would I have to move first? X. So I would get y squared equals 5 minus x squared. You okay with that?
Wait, how would work?
Your calculator has a button that says y equals. So if I want to get y by itself, the first thing I have to do is move the x squared. It's working backwards. All right? Now, how do you undo squaring?
Square root.
Square root. What happens when you take a square root over an equal sign?
Plus or minus.
Plus or minus. So y would equal plus or minus the square root of 5 minus x squared. Now, this basically means that you have 3 equations you can throw in your y equals. Let's do that. If I do that, I'm going to have, oops. First one I'll put in is y equals the square root 5 minus x squared. Next one I'll put in is the negative square root. Say what's up?
Can I have a operator for a second?
Sure. I throw that one in. That does, because there's no such thing as plus minus. Does that make sense? There's no plus minus button on there. So next, I just throw in my line. Graph it. Oop, my window's all messed up. Sorry. You do a 10 by 10 window, this should fit nicely. Sir. And obviously it's not going to be perfectly round, so it's going to look just like your football, which is nice, but you can do it. And then what you can also do then is do a second calculate to see if you're right. Intersect. If I do a second calculate intersect, I can actually see where things bounce back and forth from one another by checking curves. Okay. I think the first curve, see how it's on our the blue portion, the top half. I would hit enter. I don't want it on the second part. I want to make sure I move it over. Oops, hit the up button. So then it goes to the line. Everybody do that? Hit enter again. And with any luck, I'm guessing, no.
Your guess is wrong.
That's close enough. Intersects at 2.000002 and 0.999999996 I think that's 2 and 1. That's not cool. You guys said you don't know how to use the calculator. I'm trying to show you different ways to use the calculator.
What did you put for the second y equals?
Negative square root. Because there's no plus or minus button on the calculator. Since we took a square root over an equal sign, we have to have plus minus. That's how that's going to work. Okay?
What equation is y squared equals 5 minus
All I did here, Julie, was I took the generic equation, and our calculator has a button that says y equals. I just solved for y.
Wait, and then you put second calculate what?
Intersect. That's another way to check your work to see if it worked, see if it came out right.
Wait a second, how did you get the line over
I don't know.
I'll show you. I don't think I want you to do all of that. It's not that much. This is OB. It's not. When I'm looking at this one here, the reason why I went old book on for circles is that old book circles, they don't switch into the shifted stuff. Well, the old book doesn't shift it yet. The new book shifts everything as it goes through. I think that's too much for you guys to handle right off the bat because I've done that before and it's just a nightmare. So I want you guys to be comfortable with things centered around the origin because that way you start to work with things a little bit cleaner and then we'll start shifting things and then I'll make your lives a nightmare. I joke. I'm double checking. I'll go back. Let me just check this real fast. So it's graphs. Graph. Well, there's a mixture of parabolas in there too, so that's good. Write the equation. Find the tangent line. Yeah, these are good. Okay. What was your question? What happened was that we had x squared plus y squared equals 5. Your calculator has a button on it that says y equals. So to get y by itself, you move the x squared. So you get y squared equals 5 minus x squared. To undo squaring, you take the, and when you take a square root over an equal sign, it becomes plus. That's where it came from.
Also, Mr. Rick, I put that in my calculator.
Yeah. Oh, you forgot to put x squared, that's fine. That's fine. Because what you have there is, we haven't done this yet, but eventually we will graph y equals the square root of x. Y equals the square root of x does look like this. It does that. But what you had it reflected that direction because it was a negative x, and you had a 5 out in front of it, which meant that this problem flipped that way, but then you moved your origin to be at 5. So what you did was you graphed the square root of 5 minus x, where your initial values on the x-axis would have been 5, because that would have been 0. Yes, ma'am. Yeah, hit enter. Oh, or I'm sorry, hit graph. There's a circle. Then the last one was just we put in the equations of the line. Was it negative 2x plus something or another? That's all it was. And then we did your second calculate intersect. You just had to select between the curves. You'll have to. What's nice is the color ones. It'll show between which ones it is. Okay.